A for healthcare.
Oh, okay.
I don't know what it stands for, but
HOSA. Well, they're at HOSA, so they miss out. Okay, quotient rule. The quotient rule for f of x equals g of x over h of x is this. Okay? The first derivative of f of x equals the denominator, h of x, times the first derivative of the numerator, g of x, minus g of x times the first derivative of the denominator, h of x, all over the denominator, h of x squared.
Is it just the same thing minus instead? Like over?
No, it has an over and it's squared, so it's not the same thing as a product rule. But if you're thinking in the terms of Trey Smith, it's the same thing, except for it is a minus and it's over the denominator squared. So it's about the same thing. Okay, there we go. So make sure you have that written down somewhere. That would be a good thing to have written down. And now that you have it written down, I will move on. Well, you should know it, Trey, because it's the same thing as the product rule, and
I'm gonna write
you know.
it. You're gonna be like, oh, he does know that.
All right. So what's the first derivative of cosine x over x? So you start out with x, and you multiply it by the first derivative of the cosine, which is negative sine of x, minus the cosine of x, times the first derivative of x, which is 1 all over x squared. So to put it down nicely, it would be negative sine of x, or negative x sine of x. That's how I'd like to see it. Negative x sine of x minus cosine of x all over x squared. That's what would go in the blank. How about this crazy one with a square root involved? Well, it'd simply be the square root of x times cosine of x minus sine of x times the first derivative of the square root of x. 1/2 x to the negative 1/2 all over the square root of x squared, which is x. Now, this is where it gets a little, like in the old days of me teaching calculus, I was really a jerk about all this, but Mr. Bierschbach, older, wiser, and not so much of a jerk anymore. But you still need to figure out how to simplify this so you don't have a fraction in a fraction. So it's basically a sine of x times 1 over 2 square root of x over x, okay? So how can we handle this? How can I not have that in the numerator? Because I don't know if they'll count it right if it's listed like that in the numerator. And on the AP test, it probably will not be counted right. So what to do is to multiply by 2 square root of x, both in the numerator and denominator. x to the negative 1/2 is square root of x in the denominator. Why? Because x to the 1/2 is the square root of x, so x to the negative 1/2 is 1 over the square root of x. And then 1/2 is, yeah. Okay, so if we multiply through, we get 2 square root of x times square root of x is x cosine of x minus sine of x, and 2 square root of x over 2 square root of x cancels over 2x square root of x. Now, in the old days, I would have made sure that people had to get rid of the square root of x off the bottom as well, but no, we're good right there if we stop right there. Okay? I'm glad you totally get this, Trey. I don't know if you would have gotten there without me giving this hint, but now that I gave you this hint, you should get there when you do your assignment. What's sine over cosine? Tangent. But we're going to do this by the product rule before lunch, and then we're going to show you the tangent after lunch. Or the quotient rule, not the product rule. All right, so here we go. What would the quotient rule for this be? Cosine of x times cosine of x minus sine of x times negative sine of x all over cosine squared of x, correct? Now this is where you have to remember a little bit about your trig identities. What's cosine times cosine? Minus a negative sine squared of x, which minus a negative is? Plus a positive over cosine squared of x. Well, what's cosine squared plus sine squared? No! What's cosine squared plus sine squared? 1 over cosine squared of x. Well, what's 1 over cosine squared of x? Oh, there you go, Trey Smith. Way to redeem yourself. Secant squared of x. All right. Yeah, you're just a little lost on this, huh? You got this? Yes. Nope. You cannot cancel out where there's addition, because let's look at this. Okay, can we just cancel out the 2's? Let's just cancel out the 2's, Olivia, and you get 5, right? Or it would be 1 over 1, which is 6. Okay, because if you cancel to be 1 and 1, it'd be 6. But the answer is neither of those things. You can't cancel where there's addition, because this is really 7 halves, which is 3.5. If you multiply, then you can cancel. But in addition, you cannot. So that is why you cannot cancel cosine squareds here. Okay, Anna? Do you get the reasoning why? All right. So we'll do a little bit more of this after lunch. But what if we have tables involved? These tables are easy, aren't they, Trey? So easy. All right. So this, if we wrote this out, this would be g of x, f prime of x, minus f of x, g prime of x, over g of x squared. So what's g of x? Negative 2. F prime of x? 0. Minus f of x? Negative 4. G of x, or g prime of x? 8. All over g of x squared. Negative 2 squared. So that's 0. Minus a negative 32 is a positive 32 over 4 gives me 8. You can do that, right? Do we need to do another one of those? No? Well, then let's look at... No, we're not moving on yet. Let's look at this one then. because this one takes a little bit more to do. Okay? So again, this is g of x, f prime of x, minus f of x, g prime of x, all over g of x squared. What is g of x? 2x squared, and then when we put the number in, it's 2 times 2 squared, right? It's 2 times 2 squared, because we're working with a 2. F of x is, f prime of x at 2 is 4, because I kind of covered that prime up, is 4. Minus, what's f of x? Negative 4. And g prime of x, well, what's the first derivative of this? 4x. So it's 4 times 2, because the x is 2, over g of x squared. So it's 2 squared squared. So what's 2 squared? 4 times 2 is? 8. Times 4 is? 32. Minus negative 4 times 4 is 16 times 2 is 32. So minus a negative 32 over 2 squared is 4 times 2 is 8. 8 squared is
64.
So we get
1.
1.
You did. You did. I saw
Okay? And then just straight polynomials now. Just straight polynomials. Okay? Let's do this. So the numerator would be x minus 1 times the first derivative of the numerator, 2x, minus the numerator, x squared minus 2 times the first derivative of the denominator, 1, over the denominator squared. Now, you do not have to simplify the denominator, just the numerator. So if you do that, you get 2x squared minus 2x minus x squared minus 2. Well, what's 2x squared minus x squared? 1x squared. What's negative 2x? Well, there's not a like term, so it's minus 2x. And then it's minus 2. No, it's plus 2, because minus a negative is plus a positive. Lots of people make that mistake. Over x minus 1 squared. That is the answer. That's quotient rule. Okay? Do you want to do one more, or are we good?
We J challenge.
In the little brackets.
Because it's this goes in the brackets. 1 times that. And then minus a negative is plus a positive. Because this is just 2.
Yep.
Because this is what it was in the numerator.
Okay.
Let's do another one for Liv's sake.
Come on, bro.
Okay. So what would we start with in this one? The denominator, x squared plus 1 times the first derivative of the numerator.
X.
1
Shoot.
minus the numerator, x minus 5 times the first derivative of the denominator.
X.
Oh,
2x. Dang it.
I was so
That's
confused because
awesome, dude.
I was
That's
looking at the
on
wrong.
Over.
You're like saying
X squared plus 1 squared.
What are you doing, douchebag? Thank you. Thank you.
There you go.
That's why I was confused too.
No, you were not, Nate. Okay, so let's distribute in the numerator before we add or subtract. So it's x squared plus 1 when I distribute the 1. Minus 2x squared minus 10x. And I put that in parentheses because I have not distributed my negative sign yet. Over x squared plus 1 squared. But that doesn't change. Okay, so what's x squared minus 2x squared? Negative x squared.
Negative X.
And then 1 is just 1. And then minus a negative 10x is plus 10x, and then plus 1 over x squared plus 1 quantity squared. Okay? Sometimes you need to see a second example to get it down, but that's what we're doing today. It'll keep you fairly busy actually for the before lunch here. So, yes, Anna. Oh, hi, Kate. Yes, you do. Because Anna is kind of meek and shy when she asks questions too, and that sounds kind of like Mr. Bierschbach. Yeah. Okay, so what's up? On other stuff? On this? Okay. Let me assign this out, and then